All right. Hello. I hope. What's up? I hope this works for you guys. This is a review of the last two questions that we didn't get to do in class. My apologies for the delay. So let's get into it. So we want to write this in a piecewise function, right? So if you guys remember, right, our piecewise function is something that looks like this, right? We have f of x is equal to and then we have the bracket, and then we have like y equals mx plus b right here, and then from like p1 is less than or maybe equal to x, which is less than or maybe equal to p2, and then we have another equation down here, which is y to, let's say, m2x2 plus b2, and then so on and so forth. Okay, so we want to basically turn this into this, right? Remember, we're going to just do a little bit of background right here. Is when you draw a graph, right? When you have a graph, right? This is your x, this is your y, right? And we have our line here. Right? Let's say our line goes like this, right? Our line is going to end up equaling y is equal to m. M is going to be the slope, which means it's the rise over the run. Rise over run, right? You just need 2 points to solve for m, right? It's basically distance, right? You want to know how far away these 2 points are. So you take the furthest one and you subtract it from the smallest one. It's like saying like this is 0, this is u, that's a y. This is, let's say this is Leo, and let's say this is Jason, right? Jason, there we go. Jason is 500 miles away from 0, and Leo is 300 miles away from 0, right? How far apart, if I ask you how far away is Jason from Leo, what is the distance between them? What you would end up getting is distance between Jason and Leo. What you end up getting is you just subtract 500 from 300. And that's how you get your 200 miles, right? So now you know that Jason is 200 miles away from Leo. That's how you calculate the slope. Let's say we have these 2 points, right? We always read graphs, like how we read papers, from left to right. We always read from left to right. So this is going to be, the leftmost point is always going to be our first point. So let's say this is going to be x1, comma, y1. And this is x2, comma, x2, comma, y2, right? So our formula for the slope here is going to end up being y2 minus y1. Remember, y is in the numerator because the numerator is the rise. Y is up and down. That's the rise. And now the run is our x, so we take x2 minus x1. And that ends up being our slope. Right. So remember, rise over run, it's our rise, 1, 2, 3, whatever, to 1, 2, 3, whatever. So this is our rise, right? And then our run is right here. Okay. So moving forward, just the background, this is what slope is. And then the equation is y equals mx plus b, right? So what is our b? B is our y-intercept. What does that mean? That means our y-intercept is basically our point where it touches this line. That's it. B is where does this line touch the y, where do our function here touch this vertical line? And we look right here, it touches it right there. That is B, right there. So when you look at that, you can see something very interesting. Whenever it touches this line, x is always going to equal to 0. See, this is x equals 0, 0, 0, 0. X is 0 everywhere, right? So our y-intercept is when our x is 0, what is our b? That is our y-intercept. X is always 0 at our y-intercept, right? So that is what our y equals mx plus b is. All right, so now this is the background you need to know in terms of graphing. So now that we know this, we can go back to our function here. So now we want to split this into two different functions. So if you remember from before, when we draw an absolute value equation, our absolute value equation kind of looks like a V, right? Our standard absolute value equation, let's say it looks like this, right? So it's made up of two straight lines that change, right? So we want to split it in one equation from this line and one equation from this line. So let's say this is like the y, this is like this, and this is that, right? That's basically what we want to do. We want to make this look into these two equations. And how we use that is we use this point right here. We use this point, it's called the vertex. So when we use this vertex, how will we our first step is to find the vertex. Our first section. So let's split this up into sections. So section 1 is find the vertex. How do we do that? We use this formula. This formula will be given to you on the test, right? The formula is f of x is equal to absolute value of x minus h, close absolute value plus k. All right, here, this is our formula right here. So we want this to look like that. And then once we look like that, we can get our vertex, because our vertex is actually h comma k, right? This is what we're looking for. This is why we're worried about the vertex. We just want our h and our k. And when we get our h and our k from this equation, right, we get our vertex. Right, so let's rewrite this. Let's rewrite this down here. You have f of x is equal to absolute value of negative 2x plus 8 minus 1. Close absolute value right there. Right, I just rewrote the equation. So now what I do is I want this to look like this. Just rewriting the equation from up here. X minus h, close absolute value, plus k. Okay. Our first thing is called factoring out. So we take our greatest common multiple, which here is going to be 2, right? So I take out the 2 from here, and that means I have to take out 2 from here as well, right? So what's 2? Actually, I'm going to take out negative 2, right? Because this is a plus and this is a minus, and this is, I want the signs to match here too. So I'm going to take out a negative 2 from both of these, right? So negative 2 divided by negative 2 is just 1, right? And then 8 divided by negative 2 is just minus 4. Oh, my bad. Sorry, guys. Negative 2, close absolute value, x minus 4, close absolute value, minus 1. All right, so now this looks like this equation, and we can set our a, h, and k, right? So our a is equal to this value, right? Our a here is the one in front. Our a here is one in front. Our a is negative 2, right? Now let's look at our h, right? Our h is this value right here. All right. Our h is this value right here. It has to be minus h. This is minus h, so that means our h is just 4, right? If this minus and this is minus, that means our h is positive, right? This is already negative, right? We don't need to add a negative here. If this was positive, like for example, if this was x plus 4, right? Since this is a plus and the original equation is a minus, our h is going to end up being negative 4, right? But in this situation, the minuses match, so it's just going to be h is equal to 4. And lastly, we have our k. Our k is minus 1. Our k is here, our k is here, minus 1. All right, so now we have our a, h, and k. We know what our vertex is going to be, and our vertex is going to be vertex is equal to h comma k, which is equal to 4 comma negative 1. Perfect. All right. So now we have our vertex. What do we do now? Now we want to solve for our slope. Now we need to solve for m. How do we solve for m? We remember we need 2 points to solve for m. And we have 2 equations, right? So these equations share a point right here, right? So now we're going to go 1 over to this direction and 1 over to this direction. So actually, let's draw a little graph here, right? I'm going to draw a little graph right here, right? This is going to be 1, 2, 3, 4. 1, 2, 3. All right. And then our vertex is going to be right here, which is 4 comma negative 1. Bam. That's our vertex. That's our first point. So now we need to draw the rest of it. So I'm going to go in one direction in each side. So I'm going to pick this value and this value. Since this is 4, this is going to be 3, and this is going to be 5. And what I do now is now I have 2 points right here, right? There's going to be a point somewhere here, a point somewhere here. Now I need to know the y. I know the x for each point is going to be, this one is going to be 3 comma something, and this one's going to be 5 comma something. But how do I find out the y? Well, I'm glad you asked. We could just plug it in to our equation right here. It's that easy, right? So let's say we're calculating for point 1, right? I'm going to calculate it right here. Let's say point 1. P1, right, is equal to, and then we just take this equation, or the equation from the original question right here is all the same, and we do close absolute value of minus 2, and then what is our P1? We look down here. Our P1 is 3 because it's the point it's the x value that's to the left of our vertex is 3, right? So we do P1 is equal to 2, 8, and then we have comma 3, which we get from down there, plus 8. Close absolute value minus 1. All right, and now we solve this. This ends up being negative 6 plus 8. This ends up being this absolute value minus 1. This ends up being 2. Close absolute value minus 1. This ends up being 2 minus 1. That ends up being 1. Yeah. So now this is 3 comma 1. Now let's solve for P2. Is equal to, and then again we take our x from down here, which is 5, and we plug it into this equation to get our y, right? So our P2 is negative 2 5 times 5 plus 8, close absolute value minus 1. And now we solve. This is going to be negative 10 plus 8. This ends up being negative 2 minus 1. This ends up being just 2 minus 1, which is also 1. Sorry, I did my math. So now we know the y for the other point is going to be also 1. So now we can, let's say we plot it right here. All right, and then this is our vertex, which is 4 comma negative 1. Okay, awesome. So we have our graph here. Now how do we get our equation? So remember, our m is equal to, we have our equation for m. I'm going to write it up here, right? M is equal to y2 minus y1, x2 minus x1. So we read the graph from left to right. So let's start with the slope, or the m of this line right here, right? So we'll do m1. We'll do it right under the math for P1. So let's do m1 is equal to, so let's see. This is our first point, and this is our second point. So this is going to be our y2. So we do minus 1, and then this is going to be our y1. So y2 minus y1 divided by our x2, which is 4, minus x1, which is 3. Ends up equaling negative 2 over 1, which is just ends up being m is equal to negative 2. And now let's calculate the slope for this line, right? So remember, we read it from left to right. So now this is our first point, and this is our second point when we're looking at this line, right? So now our m2 is going to be equal to y2, which is now this one, which is 1, minus our y1, which is negative 1, which is negative 1 here. Let me get this in frame. Divided by our x2, which is 5, right here. 5 minus our x1, which is 4. That ends up equaling 1 minus negative 1 is a positive. That ends up being 1 plus 1, which is 2. 5 minus 4 is 1. So m2 is equal to 2, right? And you could see that here too, right? We go up, that means we go up 2, right? 1, 2, and to the right 1, or 1, 2, to the left 1, right? So if it goes up and to the left, that means the slope is going to be negative, or if it's going to be up and to the right, that means the slope is going to be positive. So now we have the start to our first bits, right? So we have our m, right? So we have, let's see, here. F of x is equal to, then we'll start with this line, right? So the m for this line is negative 2x, and then we have the plus or minus b, we don't know yet. And then the other line is going to be 2x, right? So the next step is we need to solve for b, right? We're going to need a little bit more paper. I'm going to continue on down here. The next step is we need to solve for what our b is. So if you look up into this equation, we don't know what our b is yet. So, but if you look at what we know from back here, our b is the y-intercept, which means where the line would touch this center axis, right? And when the b touches this center axis, that means our x is always going to be 0. So what we can do here is we can plug in 0 into our original equation right here. We plug in 0 into our original equation up here, right? So I'm going to write it down here. Extend this out a little bit. Maybe I'll zoom out just a touch. I hope you guys can see this, right? So our original equation is up here. I'm going to rewrite it down here. I'm going to put f of 0 is equal to close absolute value of negative 2, 0, plus 8 minus 1. And then there's a close absolute value right there. Okay, so 2 times 0, negative 2 times 0 is 0, plus 8, close absolute value, minus 1. This ends up being 8, absolute value, minus 1. All right, so now the next step is interesting. The next step is we actually have to split these. This is going to turn into 2 different answers right here because we have 2 different equations. We have 2 different hypotheticals here. We're going to turn this, we're going to have on one side positive 8, on the other side negative 8. Now, the reason why we do this is because kind of like looking backwards, positive, the absolute value of negative 8 and the absolute value of positive 8 are both 8. So we don't necessarily know which one it would be, so we have to do both of them, right? So we have 8 minus 1, and then we also have negative 8 minus 1. We have a positive 8 version and a negative 8 version. So 8 minus 1, that ends up being 7. So b is equal to 7, or negative 8 minus 1, b can also equal to negative 9. All right, so now the trick is, which equation does each b go to? So let's look up here, right? So negative 2, this one, is this equation right here. And we look that it's going up this way, and it's going to touch this axis on the positive side, right? So out of our 2 b's, we have a positive b and a negative b. Since this line is going to touch our y-axis on the positive side, we know that this is going to be plus 7. And now for our negative b, this one, let's say this, we theoretically extend this line here. It's going to end up touching this axis on the negative side, and we actually know it's going to end up touching it on the negative 9. The other way you could do this is you could kind of just draw it out since you already know the slope too. All right, so now our final step is our limits, right? So this is basically how our equation is going to look like, right? This goes on forever and ever and ever. So this equation can go on to -1, -5, -1,000, so on and so forth. So we'll say that this line right here theoretically starts at -infinity. And since it's an infinity, it's going to be a less than. There will be no line down here. And then you just put an x, and then this line stops at our vertex, right here, at our vertex. So all we need is the x value of our vertex, which is 4. And this is going to be a less than or equal to, because it includes the 4, less than or equal to 4. Perfect. Now our next equation, right, is this line right here. This line starts at the vertex. So our start is going to be 4. Right? And because it starts at the point, it's going to be less than or equal to x, and it goes on forever and ever and ever, so it ends up being less than infinity. And that right there is our answer to this equation. I would draw the rest of the circle, but I'm holding this with one hand. There we go. And we have our graph to go with it. Good luck, guys. You guys got this.